Hello everybody, today we're taking a look at the Hobbymate D6 Elite Charger. In the box you get the charger itself, a USB to USB cord, and a quick start manual. Taking a look around the charger, on the front you have a 2.2 inch monochrome LCD display, a jog wheel that has a center push button, and an exit button. On the back you have an XT60 power input connector and the cooling fans. On the right, XT60 output connector and your balance plug receptacle that's got anywhere between 2 and 8S. And on the left side, you have a USB port for updating the firmware with the supplied cable. And this also has a 2.1 amp output for charging other things via USB. And you also have a servo style input and output signal cable. This is what makes this a very unique charger. So let's go ahead and power it up. I'm going to use a 4200 milliamp hour 4-cell battery. You can use anything within the voltage range input. You can hook it up to a car battery. So you're greeted with 3 different functions in the settings. So you have the charger, the measure function, and the output function. We'll start off with the charger. The charger is rated at 300 watts, 15 amps. We can select which one we want here, which mode. And then here on the left, we have different memory profiles we can set up. They already have one set up for Lipo. You can select which one you want. We'll go ahead and use the default here. And so here you select the different type of battery you have. Even from here, we can change it via Lipo, lithium high voltage, lithium iron, nickel metal hydride, lead acid. So we're going to do a Lipo. Let's go ahead and get a battery to plug in. I have a 4-cell 1000 milliamp hour battery. I'll plug it here in the left on the main, and then making sure the negative is all the way down here. Plug that in. So now it knows that it's a 4-cell because it's in auto and it senses all 4 of the cells plugged in there. So we can change the maximum per cell voltage. Up to 4.25. I'm going to leave it at 4.2. Press enter. Okay, so we have auto here. If I wanted to take it out of auto and select which kind of cell it has, it goes up to 8S. Leave it in auto. Here's my charge current. I'm going to charge this at 1C, so we'll take that down here to 1 amp for 1000 milliamp hour battery. And then down here is where we decide we want to do storage, just discharge or charge. Of course, I'm charging, so I press OK. And it's charging. Currently, battery voltage is at 16.2 volts, charging 1 amp. That's 16.2 watts. And the internal temperature of the charger is 34 degrees Celsius. Once it reaches 40 degrees, the little fans will kick on. It's been charging for about 20 seconds, and it's put in 6 milliamp hours so far. Here's the individual cell voltages. You can see number 4 is highlighted here. That's because it's balancing that one right now. It balances as it charges. If I rotate the jog wheel, in a few moments, it'll give me the internal resistance of these. There it goes. Internal resistance of all the cells. So 19.1 milliohms. And if I go back over here, if I hold down the jog wheel, I can now adjust the current on the fly. So let's say I wanted to change it to 2 amps. Charge it at 2C. And there you see it jumped up to 2 amps. All right, so that's it for charging. It'll charge until it's completed up to 16.8 volts for this 4S pack. And so we can get out of this. Oh, it also tells you the state of your supply voltage. So this 4-cell right here is currently 15.53 volts. All right, so we can exit out of that. Okay, so let's take a look at some of the other functions. So now let's go to storage. Storage there. All right. So I have it set up right now to try to discharge, let's say, at 3 amps. Okay, so I'll go to storage here. So it's going to take these cells down to 3.8 volts per cell. That's the right storage voltage. Press OK, so it's now discharging the battery. So it's discharging to the internal resistor that's inside the charger. And when this reaches 40 volts, which it looks like it will, or 40 degrees C, which I think it will, looks like momentarily. So now it's discharging, and it's trying to do 3 amps, but it's using internal discharger, so it's limited to what its capability. There, the fans have kicked on here because it went over about 40 degrees C or so, and it's fairly quiet. And so it's just discharged 10 milliamp hours so far, but it can't do 3 amps because it is limited. But that's pretty good. You know, about an amp, about 15 watts is decent, and is of course balancing the cells here. But there's another way, another mode of discharging the battery I want to show you. So I'm gonna go ahead and stop this for a second. Exit back out to the settings. Go in here. And the discharge mode, I'm going to change it to recycle. Okay, so what this is going to do, this is go back into our discharge here. Or our storage. We can go backwards. All right, so now is going to essentially use this as the supply battery and discharge this and put it back into the main battery. So if you have this hooked up to a big battery and you can just much quicker, you can do this much quicker. This has a limit of 15 amps. So this can happen very quick. So so what we want to know here, we don't want to overcharge this battery. So this is a 4-cell battery. It doesn't know what kind of battery it is, but we do, and we know that we don't want to discharge it over about 16.8 volts. Let's choose 16.7 volts for a 4-cell Lipo, because then if the cells are slightly out of balance on this battery, then we make sure that we don't go too far. 16.7 is close enough. All right, so now we hit OK. So now it's going to go ahead and discharge this much stronger than it was a minute ago. It should go up to that 3 amps like we had it set. There we go. So now we're at 45 watts. And you can see here that this is all happening a lot faster. So I actually, hold this down, I can increase that. Let's say it's a 4200 milliamp hour pack. I don't want to charge it too fast, so let's just do it at 1C. There we go. So now it's discharging at 4.2 amps. So this kind of function here, I'll go ahead and stop this. But you know, that would discharge the cells down to 3.85 volts per cell, and it works exactly the same in discharge, except it just takes it down further. Instead of 3.85, it takes it down to 3.60. Again, need to set the input limit. We'll set that back to 16.7 volts in this case. Okay, so that's it for the charger style functions. So now we can go back out and go to the next type of function. So now we can, well, let's just say, for instance, that we have this unplugged, and we just want to use this like a cell checker. So if you want to use it for a cell checker, all you got to do is plug it in. Don't need the main battery, and it'll actually power up off this, and there you go. Just that quick. We have all the cells voltages, and you have the state of charge is 78% charged, about estimate, and it tells you all the cell voltages that quickly. Another function you could do, and I think I forgot to show you, but if we plug in the main battery, we'll be able to do it again. So if you just wanted to balance the cells, you can do that from right here, and then it would balance them. And these cells are pretty well balanced. You can see it shows up a little highlight on that 4 there, indicating that it's actually bringing that one down because it's just a hair higher than the rest of them. But that is another function you can do under charging. So so we can get out of that, and we can go into some of those other functions. All right, so let's do this measure function. All right, so this is interesting. So let's go ahead, and so essentially this is where we start using this input jack over here on the side. So I'll go ahead and unplug this battery. Now I want to measure something. So let's say I want to measure, it says there, I'm going to measure a pulse width modulated signal. So I need a pulse width modulated signal. So I'm going to use this little receiver right here. And I'm going to plug it in, negative, negative, and signal's closest to me. Looking for the solid light showing it's bound. There we go. All right, so now pulse width modulated, because this has a pulse width modulated output. So we'll press enter here. And as I move the throttle up and down, here, you can see the pulse width modulated signal changing. All right, so that you can use this to make sure that your channels are outputting the way you think. So pulse width modulated just one channel at a time. That's how that type of signal works in RC. So we can exit out of there. And PPM is very similar. We'll go to, let's go to Sbus. So on Sbus, I have a RXSR receiver here. Plug it in, again, same way, negative away from me. All right, green light's on, it means it's bound. So now, go into this mode, Sbus, and I can move all my sticks around here. And you can see that I'm moving the right stick now. I got one of my switches. There's another three-way switch here. And so it has all the signals coming in on the receiver. So you can see all that. So that's very handy for setting things up. You can see I got my range set up here if you want to set up to 1,000 to approximately 2,000 like you're supposed to on drones. And so if you turn this wheel here, you get the next set of channels, the 9 through 16. And then you have some of the setup here if you want to change any of these items. But that's essentially the Sbus input. And then here, this is essentially, we can unplug this now. This is essentially going back to battery type of functions. And again, plugging the battery in here. This is essentially the same kind of thing that we were doing under charging. There we go. So we've seen this screen before. And the next one is ESC. So essentially, this outputs a throttle value on this channel, and it measures the amount of power coming through the unit from your supply battery. So we need something here to test this. This is where you would test out an ESC attached to a motor to see how much it's pulling. So let me get something to try this out with. All right, so I've got a thrust stand here I use for testing out props and motors. And so there's a little ESC on the back here that I've got connected up to the motor and to the output on the charger itself. Got the 4 cells still powering on the input. So here I can hit start here, and of course I got the ESC plugged in the side here. So I can hit start here, and then it powers it up, and then I can increase the throttle. So now it's measuring the power as I increase the throttle, doing 10 watts, 0.7 amps, and of course I can blow everything around on my workbench. I can hit stop. And so essentially this is like a power meter that is measuring the power that's coming through the unit. So this is very handy. So I usually have to do that with another separate power meter when I use this this thrust stand, but with this I can do it all from just this device. So that's all of the measure functions. So now we can go back out and go to the output functions. So now we have pulse width modulated output. So we need something to test the pulse width modulated output. A servo can do that. So we can put this in here and go into this mode. And here we've got, maybe that'll kind of stay there. So now we have manual mode, where essentially we can dial in the output. Okay. Oop, we got to select that. There we go. Dial in the output. All right. All right. And then go into auto mode. There we go. Auto mode, it just goes back and forth. Again, looking at our pulse width modulated output. So that's kind of like speed. The first speed, you can set the range here. There's the second speed. You can set the range if you make it go farther if you wanted to. I want to change that, make it go further one direction. Now it's going further on the high side. You can stop all that. And so there's the pulse width modulated output. We can send a ppm type of output. If we wanted to plug this up to something like a flight controller, we can change the value of each one of the ppm outputs. Same thing for Sbus. Select which one you want to change the output, and then we can go down and change the next channel. Maybe go the other way. So you can essentially simulate or out the output out of this port back to your flight controller, whatever you're trying to change. So same idea. And then we have power. So here you essentially have a power supply that you can hook up to something. I'll just see what the reading looks like here on this voltmeter. There we go. So get this all arranged here. Turn this on. All right. So here, got it set to 12 volts. Make it anything we want. You can change the current. So since you have an adjustable output on voltage here, and you can go all the way up to the 30 volts and all the way down to 1 volt. So let's just set that on like 5 or something. There we go. There's 5. And then you have adjustable current all the way up to 15 amps, all the way down to 1 amp. We don't need much for this test. And then you can hit start. And there you go. And so you have it outputting. And so you can go over here and hold down the wheel, and you can actually change it on the fly. Okay, so that's very, very handy function. Essentially a benchtop power supply built into this. 15 amps is a lot of power. And it shows you down here the current voltage of your supply battery and the internal temperature. All right, so that's the custom where you can set it up. The other one, there's some other modes here. Get back out of here. Go back up to here, the typical mode. So you have some modes set up for some of the DJI products. Set up power supply for those. Mavic 2, Mavic S, Phantoms, Inspires. And the other one here is through. This is actually pretty handy. So if I select through, so this is essentially sending the voltage, whatever this pack is, volts-wise, 15.6 volts, to the output and limits it to whatever current you have. Now, this is handy because if you have a new drone you're setting up, I have the Hobbymate Meteor drone here, and when you first set up a drone, it's always a good idea to, when you first power it up, you've done all your wiring on it, but you want to be careful because you might have done something wrong, you might have short-circuited something. They sell this thing called a smoke stopper, which essentially limits the amount of current when you first power up your drone, and it cuts it off in case something's short-circuited. Well, you can do the same thing here. So, turn on my transmitter. There we go. So turn on my transmitter, and I'll go ahead and got it set. Let's go ahead and change this to real low current level, like 1. All right. Get ready to start it. Plug it in the drone. Got my transmitter on. All right. Drone's plugged in. And that'll work. Drone's plugged in. Press start. Okay. There's the drone's initializing. So I have right now, it's good. If it was a short circuit, it should have stopped, but it's only pulling 0.2 amps. I have it limited. Anything over 1 amp, it should stop. But let me go ahead and get this flat so I can arm it. And we'll see if we can't get that to trip when I turn on the motors. There you go. I just tried to turn on the motors, and it just tripped. So you can see here, the motor spun just barely. So this is essentially acts like a smoke stopper in this through mode setting. So that's very handy. So I will be using this every single time I set up a new drone. So that takes us through all the output settings. So we can exit here and take a look at the settings real quick. So in the settings, you have the lowest input voltage. If you're typically using like let's say a 4-cell battery pack to charge this, that's going to be a good idea to set that so you don't damage your 4-cell. Maybe like 14.5 volts, something like that. Maybe 14 volts at the lowest. Oh, there we go. Okay, so you have maximum input power. 350 watts is fine. It's a 300-watt charger. Safe temperature, 70 degrees. That's the fans will be kicking on well before that. Charge time, 120 minutes. Shouldn't take any longer to do that. There's that recycle. Oops. There's that recycle versus internal. Then you have Sbus value. This changes how the Sbus values are shown when you're in the measure mode. You have backlight, obviously if we change the backlight on the LCD, contrast, buzzer tone. It's not volume, it's more like pitch. Okay. You have the idle beep. Essentially, when it's not doing anything, it'll sit there and beep to tell you that you still got the battery hooked up, and you don't want to obviously discharge your main battery if it's you kind of forget about it. And then you have the language. And you have the settings that you can use to default the settings back to the original factory defaults. You have the serial number of a charger, essentially, and the firmware version. All right, so that's all the settings. And the last thing I want to, one of the last things I want to show you is we'll get the drone unplugged here. All right, so here, if we unplug this, there is a way to calibrate this. If your voltages are a little bit off, you hold down the button and you plug it in. Here it brings you up to the calibration screen. So you measure the voltage of your main pack with a digital voltmeter or something like that, and you measure each one of the cells with a digital voltmeter, and obviously those all added up equal the main voltage. And when you plug those in here, you can adjust them after you already know what they are. You got to have them written down ahead of time. And you can go through here and you can adjust the values if they need a slight adjustment. Like, so if this really wasn't 16.688 volts, you'll be able to adjust it here. Press it down and make a change. So you'll be able to do the same things for each one of the cells. Once you get done, you can save. I'm not going to change anything, so I'm just going to hit exit. All right. And so the last thing I want to share is for updating the firmware. So when you update the firmware, you get your new firmware file downloaded on your computer. You plug this into, you plug the supplied USB to USB cable into the USB port, and then you plug it in your computer. And what happens is this has a small amount of memory inside it. So it shows up as a drive on your computer. So all you got to do is drag the file, you remove, there's already a file on there, which is the firmware. You can have that as a backup. Probably a good idea to copy that onto your computer. And you drag the new file, firmware file on there and copy it on there. You power it back up. Next time it'll update the firmware. So that'll do it for this video. There is a detailed user manual on Hobbymate's website, a download page. I'll put a link to that in the video description. Thanks for watching.